no matter what, as long as you choose an x value that's pretty close to x equals a, which is the point of tangency, the tangent line, the linearization, is a pretty good approximation of the function. Sometimes, if we have more specific information, we can know if that tangent line, the linearization, is an overestimate or an underestimate of our function. So watch this. You have this picture on your notes paper. On an interval, a function can only do one of four things. Four combinations are possible. A function could be concave up and decreasing, like the top left corner. Could be concave up and increasing, like this function in the top right corner. Could be concave down and decreasing, or it could be concave down and increasing. These are the only four combinations of increasing, decreasing, and concave up, concave down. So notice that I've drawn in the tangent line to each of these four kinds of functions. And notice that for two of these, the tangent line lies below the function curve. And for two of them, the tangent line lies above the function curve. So you can see here, this is a big deal. It turns out this is always true. For functions that are concave up, like the top two functions here on this slide, the tangent line is always below the actual curve. It touches exactly at the point of tangency, and then everywhere else it lies under the curve. That means for functions that are concave up, the tangent line approximation is an underestimate, because we're going to use values on this blue line to predict the function value, but all of those blue line values, they're actually underneath the red curve. So functions that are concave up, for functions that are concave up, the tangent line approximation is an underestimate. Similarly, for functions that are concave down, the tangent line approximation, or the linearization, is an overestimate. So here we go, we've got it in writing. The linearization of a function f of x at x equals a is an overestimate on any interval on which f of x is concave down. And you probably have to draw yourself this picture a couple of times. I had to draw myself this picture when I was in calculus. So if I have a function that's concave down and I try to draw on the tangent line lies above. And so, again, you could use the tangent line approximation, the linearization, as a estimate for the function value anytime you want. But sometimes on the AP test, we'll have an extra piece of information and we'll have to say whether our approximation is an overestimate or an underestimate. The key lies to the concavity of the function that we've been asked to write the tangent to. And so I've got an important note here. In order for us to really know if our tangent line approximation is an overestimate or an underestimate, I have to know about the concavity for the function, including the interval that contains both the original point of tangency, so x equals a, and the x value where I've been asked to compute to approximate the function value. We'll do an example in the next slide.